Okay, here's the projectile question from the homework. So we've got a particle that is projected that is projected into the air, point O, and it's projected with the initial speed of 13I plus 20J. So 13I plus 20J meters per second. Okay, from O. Okay, and then the particle moves freely under gravity as it lands on a platform. So it lands here on some platform that is 20 meters above the ground. Right. Now we're going to work out the horizontal distance traveled by the particle. So remember, basically, we're moving in 2 dimensions. So the first thing we do is we're going to do the horizontal because it's really easy. Okay, we know that the distance it moves horizontally is the initial speed times the time, because acceleration is 0. So the other half of at plus at squared. This is 0 because a is 0. Right. So now we know basically that s is equal to u. Well, the horizontal component of that is 13, and the t we don't know yet. Okay, so that's our horizontal for now. So now let's look at the vertical. What do we know? So we'll do s u v a t. Okay, so we know that it's got to get to 20 meters. So we're going to put our displacement at 20 meters. We know the vertical component of speed, that was 20 for our initial vector. We don't know what v is, that's the thing we want. And we know the acceleration, as it's moving freely under gravity, is minus 9.8, as we've picked up as our positive direction. Okay, so now if we go back to the same equation, s equals ut plus 1/2 at squared, okay, we want 20 to be equal to 20t. Half of a is going to be minus 4.9 t squared. Well, let's rearrange that. So 4.9 t squared minus 20t plus 20 equals 0. Now we'll find the solutions for that. We find that c is equal to 2.329 and 1.7522. Well, if we think about it, if this is our 20-meter line, there are 2 places, here and here, where it's 20 meters. So the first one is 1.7522. That's not what we're interested in. We want the second one. So now what we do is we'll go back to our horizontal equation and we'll substitute our t. So 13 times 2.329, and then that gives us a distance of 30.3 meters. And that is part A taken care of. Now we'll do part B. We want the speed with which the particle strikes the platform. So again, we'll think horizontally. Well, there's no acceleration, and u was equal to 13, so that's not going to change. Now, going in the vertical direction, we want speed, so we're going to do v squared equals u squared plus 2as. So v squared is equal to u squared. Well, u was 20 in the vertical, so that's 400, minus 2 times a, so that's minus 19.6, and our s is 20 meters because the point we're looking for is 20 meters above the ground. Okay, so from that we find that v is equal to the square root of 8. So now, to find the speed is a magnitude. So my vector that I'm looking for is 13 root 8, and the magnitude is the square root of 13 squared plus the square root of 8, all squared. And when I do that, it gives me the square root 177, which is about 13.3 meters per second. And that is my speed that takes care of part B.